My tool was the spectroscope, and a spectroscope is commonly used in astronomy, more specifically in spectral analysis, which is commonly used to find out the composition of unknown materials. And this tool is actually the most commonly used tool in spectral analysis. And this is what a spectroscope does, is it takes the light from an outcoming source, puts it through a prism, and splits it up over a spectrum to determine its chemical composition and properties, which is basically exactly what spectral analysis is putting things through a prism and analyzing it through a spectrum. This is a graph showing the intensity varying throughout the different levels of the spectrum, and knowing the intensity of the light at different wavelengths allows scientists to determine what makes it up, or its chemical composition, and even the rate by which the light is moving. So the intensity actually shows us a lot. So using the spectroscope actually shows us a huge amount of information about what the light is and where that light's coming from. The spectroscope has many different structures. One of the most common structures is the one that I showed you first. This one is a small handheld spectroscope. It's not as efficient, but it still works pretty well. And surprisingly enough, this tool is actually easy enough that you can make your own. It's not going to be as efficient as the high-tech one that scientists use, but it's still pretty decent. It's almost like the Eclipse tool that you can make out of like a cardboard box or something. This works pretty much the same way. It's just not as efficient, but it still works. And my question for you guys is actually, what is this called? This is actually called a spectrum, which is used to diffract light into all different wavelengths.